So today's class is angular momentum. Angular momentum. What is momentum? Amount of motion. Amount of motion contained in a body. Amount of motion contained in a body is called momentum. It is represented by P, which is equal to the product of mass and velocity. So in momentum, you have how much amount of motion or velocity or speed is contained by a body, that is called the momentum, and we say it linear momentum. We say it linear momentum. But what is angular momentum? Suppose a body moves in a circular path. Suppose a particle of mass m moves in a circular path whose center is suppose O. The speed of the particle suppose say v, and the mass is at a distance r from the center of the circular path. Then in this case you cannot find out the momentum of the body. Here you have to calculate the angular momentum of the body. That means in addition to the momentum, if you have a mass, you have a momentum mv, which is equal to p. You have defined, but in case of a circular path, circular motion, instead of linear momentum, we take angular momentum, where we have extra term, that is your r. So here angular momentum L is defined as mass into velocity into the distance from this point to this point, this distance. If this mass moves in xy plane, suppose the mass is moving in xy plane, that is the plane of this whiteboard, then this vector, angular momentum vector will lie perpendicular to the line, perpendicular to this plane. Suppose to this plane, angular momentum is along a line which is perpendicular to this plane. This is your xy plane. This is your suppose x axis. This is your suppose y axis. So this plane, this board plane is your xy plane, and your angular momentum is along the z axis. Z axis is perpendicular to the board. That means the z axis will be, suppose this is your z axis. So this will be the direction of the angular momentum, L or L vector. But this is, you cannot write the angular momentum like this, mvr. It is a cross product. It is a cross product of mass into velocity, cross product with r. Okay. Cross product of velocity with r, or cross product of the momentum with r. Why? Because when you take the angular momentum, suppose the linear momentum makes an angle theta with the x-axis. Then you have two components of the linear momentum, one along y, another along x. At this particular point, what will be the magnitude of the linear momentum along x-axis? There is no linear momentum along x-axis, only linear momentum along y-axis. That means the momentum P, which is equal to mv, it depends upon this angle theta, and this angle is called, dependence is called sine theta. That means the velocity depends upon sine theta. Okay. So you can write the linear angular momentum L is equal to m v r sine theta. Okay. So there is a problem whether you take v sine theta or you take r sine theta, or when you take v sine theta and when you take r sine theta. Remember, when the linear momentum is changing, you take v sine theta. That means you write the angular momentum as m r v sine theta. Okay. Ultimately, this will be equal to m into r cross v. Okay. The final result will be same. But when velocity is changing, you take v sine theta component or magnitude of v sine theta. If the velocity is fixed, that means the motion is uniform, you take r sine theta. You represent L as m v r sine theta. Okay. So remember, angular momentum in two ways. One is your m v r sine theta. Ultimately, this will be equal to m into r cross v or v cross r. Same. Ultimately, same result you will get. But you have to, for problem, you have to remember whether L is equal to m r v sine theta or L is equal to m v r sine theta. Why it depend upon r? Suppose the particle, the momentum of the particle, suppose I am taking the momentum along this direction. This is the momentum mv of the particle. Okay. This is the angle theta. This is the angle theta. You join this. So this angle also will be equal to theta. This is your r. Then what will be this value? This will be equal to r sine theta. So when the particle will change its position, r sine theta will change. So long as r sine theta is constant, the angular momentum will not change if the speed is constant. Remember, if the speed is constant, there will be no change in the angular momentum if this value r sine theta will be constant. For example, suppose a body moves with constant velocity along this line. You take 2 points. Suppose you have 2 points, one point A, another point B. And the velocity of the body is uniform, constant. Whether the angular momentum at A, will be equal to the angular momentum at B, or it will not be equal to, angular momentum at A will not be equal to the angular momentum at B. Which is correct? This one will be correct. angular momentum at A will be equal to the angular momentum at B, because for this value, you see, suppose I am joining these 2 points. The 2 points are changing, you see, the 2 points are changing, but the velocity of the two above the body is constant or uniform. But this distance, that means the distance from the considered point to the point where you are generating the angular momentum, this distance r sine theta, this is fixed. Since r sine theta is fixed and v is constant, LA must be equal to LB. Angular momentum at A must be equal to angular momentum at B. So you have to remember the physics of angular momentum, 2 things. Angular momentum depends upon 3 factors. Angular momentum depends upon 3 factors. Number 1, it depends upon r. If r is equal to 0, angular momentum will be equal to 0. Suppose you take the angular momentum here at the center, then it will be equal to 0. If the angular momentum of the body at here is equal to L, what will be the angular momentum at here at the center? It will be equal to 0. So it depends upon r. Number 2, it depends upon r sine theta, or it depends upon theta, this angle. Number 3, it depends upon v sine theta, or the velocity component. So you have to remember these 3 things. Problem from angular momentum will come if you know these 3 things: how the angular momentum changes with r, how the angular momentum changes with the theta, and how the angular momentum changes with the v. Then you can answer all the multiple choice questions. The next thing is, in Newton's second law of motion, we know the change in momentum, rate of change of momentum is equal to force. That means if there is no force, in the absence of force, there is motion of the body, but when force is applied, the motion of the body changes. When the motion of the body changes, the momentum will change. That is why the rate of change of momentum will be equal to the force. Similarly, what will be the expression for the angular momentum? We have deduced the angular momentum L is equal to m into r cross v. You got it? So what will be the change in angular momentum? The change in angular momentum will be equal to so the change in angular momentum depends upon which factor? Which factor? It depends upon a factor which is called torque. Instead of force, here this will be equal to force, because when you take the derivative of mass into velocity, what you will get? Mass into acceleration, which is nothing but force. So here what you will get? If you take m common, then what you will get? R cross, what will be F, and that will be equal to torque tau. Okay, so in linear momentum, force is required. In angular momentum, torque is required. That means when torque is applied, the angular momentum will change. For symmetric object or for point object, the angular momentum is along the, suppose here, z axis. If the symmetry will change, if the symmetry of the body will change, then the direction of the angular momentum also change. Okay. This is your dp r cross p, not f, r cross p, derivative of v with respect to this one. Okay, r cross p. So now you are acquainted with the angular momentum of a single particle. Angular momentum, for a angular momentum of a single particle, the rate of change of angular momentum is equal to the torque. For large number of particles, n number of particles, or for system of particles, we take the vector sum. We take the vector sum of this thing. That is, you will write the derivative of vector sum of L with respect to t, that is equal to dy dt of r cross p. You take the vector sum in case of system of particle. In case of a single particle, you take dl by dt equal to this one, and for large number of particles, you take the vector sum. So this is a little bit discussion about the angular momentum of a single particle and for a system of particles. So you have many problems in angular momentum. So you write to me in the comment section the problems or anything what I have left. I will answer you. Thank you.